All right, let's go through the 2020 MCAT Day One, so the Tuesday one. Pretty nice MCAT actually, everything seems quite achievable from copying all the questions down onto some lined paper because I don't have a printer. So let's get into it. Let's see if we can do this video one take and less than an hour because that's what we have for the MCAT. All right, question one. Obviously going to be an achieved question. It is just a straight substitution. Find the value of 3x squared plus 8 plus 2y squared plus x squared minus 2. And we know that x is 2 and y is negative 3. Pretty nice problem. Just remember your order of operations. So 3 times x squared, so 2 squared, plus 8 plus 2 times y squared. I'll put that in brackets because it's a negative, plus x squared, which is 2, sorry, x is 2 squared, minus 2. Now we're going to do all the powers and then multiplication. So that's 3 times 4. Then we've got the 8. We've got 2 times 9 because negative 3 times negative 3 is 9, plus 4 minus 2. I'm going to be a little sneaky. I'm not going to add those 2's because they're going to cancel out. And I have 12 and 8. Sorry, that's plus 2 times 9, so I can't actually cancel those 2's. First mistake, straight away, it's not a good sign. Plus 18 plus 4, then minus that 2. Okay, so I've got 20 and 22 is 42, and so 40 should be the answer to that first one. Okay, straight into solving an inequality. Wow. Okay, rough. We get into it pretty quick. So the only thing we need to remember with an inequality is that if we're changing signs, the inequality is going to change. So an example I always use is that 3 is obviously greater, it's obviously strictly greater than 2. And if we multiply or divide both sides by -1, then we're going to get -3 and -2, which obviously changes that inequality. So that's the only thing we have to be careful of, is when we're changing signs. I see a lot of brackets, and when I see a lot of brackets in MCAT, I like to just expand those out. So we're going to get 3 times 2, 6, minus 3x, minus 6x, minus 2 is greater than or equal to 14 minus 14x. Okay, now I stop and I think, well, if I add 14x, am I going to get positive x's on this side? I am. Otherwise, I'd probably add these x's over to there because I just want to keep my number of x's positive. So maybe before I do that, I might just tidy this up. 6 and -2 by collecting like terms is 4, and I've got negative 9x is greater than or equal to 14 minus 14x. Adding 14x to both sides and subtracting 4 is going to give me 5x greater than or equal to 10, and so x is greater than or equal to 2. And that is the answer. Okay, achieved quite a high level, possibly, probably merit because it's a linear inequality. If it's a non-linear inequality, it's going to be excellence. Okay, now we want to solve this thing. So we've got 3 over x plus 2 plus 5 over x minus 4, and this is equal to 2. Now, it's these denominators that annoy me, so I want to get rid of the denominators. So I'm going to multiply everything through by x plus 2. That's going to cancel that out. So I'm going to get 3 plus 5 times x plus 2 over x minus 4 equals 2 times x plus 2. Now I'm going to multiply everything out by x minus 4. This is just one way of doing it. Because I'm not into algorithmic approaches like, oh, just cross multiply or do the upside down picnic table. I like to actually understand what I'm doing mathematically. Okay, it's the MCAT. I've got lots of brackets. I'm probably going to need to expand this out, and it looks like it's going to be a quadratic. So I'm going to need this whole thing to equal 0. So expanding, I get 3x minus 12 plus 5x plus 10, and that's going to be equal to, I'm just going to leave the 2 and expand this out as a quadratic. X squared minus 2x minus 8. Collecting like terms over here, 8x minus 2. So 3x and 5x is 8x, negative 12 and 10 is negative 2. And this is equal to 2x squared minus 4x minus 16. It's a quadratic and I want it to equal 0. So I'm going to have to get rid of the 8x minus 2 off both sides. So I'm going to subtract 8x and I'm going to add 2 and I'm going to do that to both sides. So that 0 is equal to 2x squared minus 12x and minus 14. So 2x squared minus 12x minus 14. Hopefully that's correct. What I notice now is I've got a common factor of 2. So I can either factorize that out, or if I divide everything by 2, then it's going to simplify this problem. Now you can't divide by 0, but 0 can be divided by anything. So 0 divided by 2 is still 0, and we're left with x squared minus 6x minus 7. This is pretty hard to solve, so I can solve the product of two things equaling 0, so I'm going to have factorize. It's a nice one. It's going to be negative 7, positive 1, and then my solutions are x equals 7 makes this bracket be 0, so it'll be 7 minus 7 is 0, 0 times 7 plus 1 is 8, so 0 times 8 is 0, so x is 7, x is negative 1. That's probably an excellence question, so we've gone achieved merit excellence straight away in the MCAT. So there's our solutions there. So if you just got 7 and negative 1, that would be for question 1, you would have, I believe, if 0, there'll be a D, but if you just got this, you'd have an E7. If you just got this, you would probably have an M5. So we're at 7 points so far. Okay, there's part D. Don't worry, I'll be reusing all the backs of these bits of paper when I'm doing some other maths. So we want the total area of all three shapes given that x is 6 centimeters and that adding x, y, and z equals 12. Okay, so what is the area of this triangle? So it's half the base times the height. So that's just half of 2x squared. So the half and the 2 cancel. This area is x squared. The area of the rectangles is even easier. That's just xy, and this is xz. So adding those areas up, we have x squared. So I'll go area is x squared plus xy plus xz. Now, what do we notice about all these terms? Because we need to be using these bits of information somehow. Well, there's an x term in all of these. What happens when I factorize that out? Because it's one of the key skills for the MCAT is factorizing. So x is going to leave x plus y plus z. Ah, voila. We know that x plus y plus z is 12, and we know that x is 6. So the area is simply 6 times 12, 72, and it's, you want to answer in context, centimeters squared. There's your answer, and that's not too bad. That's another excellence question. So if we got that, and the other one, takes us to 8 points, takes us to an E8. That's a really nice problem. I believe they give you the area of a triangle, so you don't have to remember half base times height, but that's pretty elementary. Oh, there is a part E, so another opportunity to get an excellence question if you missed one of those two. Okay, 8 to the power of x times 4 to the power of x squared minus 6 equals 4. So this is a this is an exponential algebra problem. Pretty hard to solve unless you're using logarithms, which is in year 12 NCA. However, we don't have a calculator, and we do know our power rules. So 8, 4, and 4, we want them all to be the same base number. So can we reduce them to the same base? Well, 8 is 2 to the 3. 4 is 2 squared. Okay, well 2 to the 3 is still raised to the power of x, and 2 to the 2 is still raised to the power of x squared minus 6. And we know this rule. X to the a to the b is x to the a times b. Okay, that's just one of our basic algebra power rules. So this is just going to be 2 to the 3x times 2 to the 2x squared minus 12, because that 2 is going to multiply that whole power, and that equals 2 to the 2. Our other power rule is that x to the a times x to the b is x to the a plus b. So when we multiply and the bases are the same, we add their powers. So this is just going to be 2 to the 2x squared. I'm going to write this a little bit bigger. 2 to the 2x squared plus 3x, because we're adding these powers, minus 12, and that's equal to 2 to the 2. Now that the bases are the same, I'm running out of room, so I'm just going to chuck some more paper in. Now that the base numbers are the same, and we've got an equality, we can just equate the powers. So 2x squared plus 3x minus 12 is equal to 2. Because the bases are the same and they're both raised to some power, we can just equate those powers. So we need, again, we're solving a quadratic, it has to be equal to 0. So we're going to subtract 2 off both sides. Easy. Okay, now I check, do I have a common factor? 2, 3, and negative 14 is not easy to factorize. However, we do have a method. Take that first number and that last number, multiply them together. So negative 28. We want factors of negative 28 that are going to split 3. So 7 and 4 is probably going to do it. Which one needs to be negative? The 4, because that's going to give us the 3. Okay. 2x squared. Now we'll split this 3x into 7x and minus 4x. Doesn't matter which way around you write them. I'm going to write negative 4x plus 7x minus 14 equals 0. Notice this is still the same quadratic. I haven't changed it, so I'm still going to get the right answers, but I've turned this into a 2-part factorization. It's going to be nice and easy. I'm going to put a line down the middle, factorize this side, 2x, x minus 4, plus what can come out of this side is 7, that's a 2, minus 2 equals 0. Now that's a factor, the x minus 2, and that's a factor, 2x plus 7. Okay, so one solution, x is 2, other solution, negative 7 over 2. And if you need that proven, obviously this bracket could be 0 as well, so 2x plus 7 equals 0. 2x is negative 7 by subtraction, x is negative 7 over 2. So we know now that we can quickly write that answer as negative 7 divided by 2. So yeah, should have probably given myself a bit more room on that one. How do we do it? Same bases, using our power rules to bring this problem down to same base with some power, equate the powers, and then unfortunately had a pretty tricky factorization problem to deal with. So that's like that is a true MCAT excellence. That's probably one of the hardest ones in this paper, but if you've done enough of your power rules and quadratics, then they come together quite nicely. Okay, Question 2. Back to something easy. Height of a person is h centimeters, and their length of their forearm is f centimeters. And we've got this quite simple connection between their height and the length of their forearm. So their height is 3 times their forearm plus 100. Now we want to solve for f. So we know their height is 160, so h is 160, and we don't know their forearm, so their forearm is still f. So 160 equals 3f plus 100. So all we have to do here is subtract 100 and then divide by 3. So a 20 centimeter forearm, because I'm always answering in context. I always want to be careful that the difference between me and another MCAT candidate is that I'm answering in context. You never know what might be the separation for that grade. Okay. Find the area of the picture in terms of x. And we want the area in the form ax squared plus bx plus c. So the general form of a quadratic. Okay, well, the width of this frame is x everywhere, and this is the picture. I'm not going to try and draw it, so we want to find the area of this picture in terms of x. Okay, well, the height of this picture, because it's a rectangle, we need base times height, is we know this is 5x plus 2, but if we take off an x, we're going to get the height, so that's 4x plus 2. That's the height. The base, we know this total piece of framing is 7x plus 3, so the base is going to be 7x plus 3 minus that width x, so 6x plus 3. That is the area, and usually that's good enough, but they want it in this general form, so we're going to have to expand this out. Now expanding, you're probably quite confident, but I suggest you take a bit of care when you do this. So 4x times 6x, 24x squared, 4x times 3 is 12x, 2x times 6 is 12x, and 2 times 3 is 6. Collect your like terms. We have 24x squared plus 24x plus 6, and that is our area written in the form ax squared plus bx plus c. Not too bad. I believe that's probably a merit question. Okay, next one. 2c. We're wanting to solve this non-linear inequality. So straight away I know this is an excellence question. It's an inequality, but it's non-linear. It's got powers. Okay, first things first, probably want to expand this bracket out. So 9x squared minus 30x plus 25 is less than or equal to 3x squared plus 1. And just like when we're solving quadratics, when we're doing quadratic inequalities, we also want 0 on one side. So I'm going to subtract 3x squared and 1 off both sides. 6x squared minus 30x plus 24 is less than or equal to 0. Okay, well, just like earlier when we're trying to solve a quadratic, we can actually divide everything through by positive 6, and it won't change that inequality because I'm dealing with a positive. So let's divide everything by positive 6. X squared minus 5x plus 4 less than or equal to 0. And just like solving when it's equal to 0, just like solving a quadratic, we'll want this in factorized form. X minus 4, x minus 1 less than or equal to 0. And it's actually quite useful to have done a wee bit of tables, equations, and graphs. Tables, equations, graphs because it helps with the intuitive understanding here that this is a parabola. And it has got two solutions where it goes through the x-axis. One is at 4 and one is at 1 when we solve this. Oh, round that way. 1, 4. So we know that it's less than 0. It's below the axis in between those two values. So x has to be less than or equal to 4. It's allowed to be equal to because when it's equal to 4, it's 0. And x greater than or equal to 1. So in between those two values and at those values themselves, it's less than or equal to 0. The more algebraic approach would be, you know that x equals 4 and x equals 1, solve this, and just check a point in between. So a point in between 1 and 4, say 2, is that less than 0? So we'll check. This is just another way. Check x is equal to 2. That's going to be 4 minus 10 plus 4. What's that value? Well, that's negative 2. It is in fact less than or equal to 0, so it must be in between 4 and 1. But I prefer that graphical approach. Okay. Next question. Okay. A rectangular piece of paper, PQRS, is folded along the line FH, so that P is moved to G. We know that FP is 2, PH is 3, RS is x plus 3, and QR is 2x minus 5. Find the perimeter of the shaded region in terms of x. Wow. So there's a lot of information to deal with here, and it can be really overwhelming, and it's obviously going to be an excellence question by the looks of things, but if it comes out to be quite simple, it's probably going to be more like a merit. So what you want to do is you want to stay cool, keep a cool head when you see something like this, because sometimes these are actually easier than they might look. We want the perimeter of this shaded region. So we're going to be finding this length here. We want all of that. So we definitely want 2x minus 5 and x plus 3. But what about these lengths here? They look quite complicated. Well, think about how you might fold a piece of paper. When this piece of paper gets folded like this length here and this length here, notice that it's going to be the same perimeter as the piece of paper that you had originally. So all we actually really need to do is have two lots of 2x minus 5, this length and this length, and two lots of x plus 3. That is the perimeter. It says find the perimeter in terms of x, so technically you could leave it as that, but I think they'll want that fully simplified. So 4x minus 10 plus 2x plus 6 is 6x minus 4. That's your perimeter in terms of x. So it looks really tricky, but it's not really, because the length of GH and HS is just this total length here, and the length of FP and FG, well, that's just this 2 centimeters part here. So pretty simple. It's a merit problem because there's only 3 lines of working. All right. Next question. Now we want the area. We want to find x so that the shaded area is 24 centimeters squared. So we're gonna have to bring this picture back in. We want the area of the shaded part. So we want to take away the total area of the rectangle. So 2x minus 5 times x plus 3. That's the total area. And we're going to take away this triangle. We're actually going to take away 2 of that triangle because it's been repeated when we fold that corner up. So the area of this triangle is half base times height, so 2 times 3. 6, halve it, So the area of that is 3, and so the area of that is also 3. So we're actually going to be taking away 6. That's the total area. Now it says that the shaded area is 24 centimeters. So we're actually going to be solving and figuring out what x is. So we're going to be figuring out what that x value actually is, given there's a certain area. So 24 is 2x minus 5, x plus 3, minus 6. It's a quadratic that we're trying to solve. So we're going to have to expand, simplify, make it equal to 0. 24 is going to be 2x squared plus 6x minus 5x minus 15, and we still have the minus 6. Can't forget about that. We'll leave the 24 for now, and we'll just collect like terms. 2x squared. Now I've got positive x, and we have negative 21. Okay, now we can make it equal 0. 0 is equal to 2x squared plus x minus 45, I believe. So now we want to solve this, and again, there's no common factor we can divide out by. So what we're going to have to do is that method where we multiply the first and last term, get negative 90, and we want factors of negative 90 that split to make 1. Well, 10 and negative 9 should do the trick. So 0 equals 2x squared. Now last time I took the 2 and matched it with the other multiple of 2. I'll just do it the other way around to show you that it doesn't actually matter which order you do those. 2x squared minus 9x plus 10x minus 45. So I know I'm making it a little hard on myself, but just want to give you guys the experience of if you wrote those around the other way. So we've split the 1, because negative 9 and 10 is 1. So I've just split that up into the factors of multiplying first and last. What can we factorise out of this first half? Well, we can't take a 2 or a 9 or any common factor of those numbers, but we can take x, leaving 2x minus 9. What can we take out of 10x and negative 45? We can take a 5 out, a positive 5, leaving 2x minus 9. Well, that's good. Same bracket. That's one factor, 2x minus 9. The other factor, x plus 5. Solving this for 0, x can be either 9 over 2 or 4.5 centimeters, or x can be negative 5. Well, can't have that, can't have a negative length, so that is our answer. X is 4.5 centimeters. And that's definitely got to be an excellence question. Okay. Right, we're into question 3. I don't know how we're doing for time, but it feels pretty good. Question 3. Find x knowing that the angles in the quadrilateral sum to 360. Haven't given myself much room here. Go up here. So we know that all these angles add to 360. So let's start with this one. 11x plus 40 plus 9x minus 40 plus 10 lots of x minus 3 plus 6 lots of x plus 5, and this equals 360. So expanding and simplifying, we have 11x plus 40 plus 9x minus 40 plus 10x minus 30 by expanding plus 6x plus 30 equals 360. Collect all your like terms and solve. Your 40s cancel, your 30s cancel. We have 11x and 9x is 20, 10x is 30. We have 36x equals 360. So x is obviously 10, because 10 lots of 36 equals 360. So, nice achieved question there. Just summing everything up. Okay, this is a cool problem. I realise I've forgotten to put the R value down. I think I've got a tab open of the question somewhere. That's annoying. 418. Okay, so this curve, this parabola, is of the form y equals ax squared plus bx plus 2. We want to find a and b, and we know that negative 113, the coordinate negative 113, and the coordinate 418 satisfy this equation. So when I plug negative 1 and 13 into this equation, then that'll give me one equation. Let's see what that looks like. So y is 13, x is negative 1, so that's just negative 1 squared is 1, so that's just a. So negative 1 times negative 1 times a. And x is negative 1, so a minus b plus 2. There's one equation. The other equation we have is when y is 18. We know that we have 16a because we've got 4 squared times a, so 16a, and 4b. Okay, we still have that positive 2. So this is an example of that elimination method. Elimination method solving simultaneous equations. Okay, now I could subtract the 2's and all of that, but I don't have to. But it might be nice just to tidy this up. So what I'm going to do is I'm going to subtract 2. I will subtract 2 off both of these. And so these equations will become 11 is a minus b. 16 is 16a plus 4b. I'm going to multiply this equation by 4. 44 is 4a minus 4b. 16 is 16a plus 4b. The reason I multiplied by 4 is now that the sign is the same on these variables, b, when we add these equations together, the b's are going to cancel. So 44 and 16, 44 and 6 is 50, and another 10 is 60, and that's equal to 20a, and the b's are gone. So 60 over 20 is 3, so a is 3, and now I want to get b. Now I could put a back into this or this, but I might actually go all the way back to this one because it's the simplest linking of a and b. So 3 minus b is 11. 3 minus b is 11. So I might add b and subtract 11. What's that going to be? Negative 8. There we have it. There is our solution to quite a cool excellence question. Now we know that these points satisfied that equation, so we knew that when we put those values in, it would retain equality. If we put that one in, it would retain the equality, giving us two equations with two unknowns. When you've got two equations and two unknowns, you can usually solve them, especially in the MCAT. Alright, that's 3a and 3b done. Let's have a look at 3c. Okay, now Terry is 5 years old. Mari is 4 years older than Terry. So in how many years will Terry and Mari ages multiply to 77? So, well, Terry's 5. So 5, and then we'll add the number of years that it's going to take to get to multiplying to 77. So we don't know what that number is. So Terry's age plus x, and we're going to get Marty's age, but Marty is 4 years old, so she or he is 9. And if we add the same number of years and then multiply, we should get 77. So a 5-year-old plus that number of years, a 9-year-old plus the same number of years multiplied together should give 77. Right, when we expand, we should get x squared plus 14x plus 45 equals 77. Okay. Subtracting 77 off both sides, because it's quadratic, we want this to equal 0. That's going to be a little tricky without a calculator. So 40, a bit of a mind blank. 45 minus 5 is 7 is a difference of 2. That's, okay, minus 32 is equal to 0. So now we just have to factorize and solve because it's quadratic. So we want this in double brackets. At least it's a simple one this time. It's not one of those complicated ones or ones with a common factor. Factors in negative 32 to give 14, 16 and negative 2. X plus 16, x minus 2. The only solution in this context is x equals 2. So in 2 years, their ages would multiply to 77. And that makes sense because in 2 years, Marty would be 11 and Terry would be 7. So 11 times 7 is 77. Okay. The next one, probably looking at an excellence problem now because we're simplifying. Oh, that one is probably merit. This 3D, simplify 4x squared minus 25 over 2x squared minus x minus 10. That's probably going to be an excellence question. The first thing I notice is that on top I've got a difference of 2 squares. So the numerator is going to become 2x minus 5, 2x plus 5. And it's pretty typical for one of these brackets to cancel with a bracket in the denominator in the MCAT. But I might just go ahead and I'll factorize this 2x squared minus x minus 10 off on the side first. So first times last, because there's no common factor, negative 20. Factors in negative 20 and split the negative x. 2x squared minus 5x plus 4x minus 10. Factorize this side, only an x can come out. Factorize this side, only a 2 can come out. And that is in fact one of our brackets, isn't it? So this actually comes out to being x plus 2, 2x minus 5. So if we write that over here, 2x minus 5, so factorize the top and bottom, x plus 2, we can see that anything divided by itself is 1, so those are going to cancel out, giving us 2x plus 5, x plus 2. Not too bad. The difference of squares is obviously quite a high level factorization. That's what makes this an excellence question. I think this is the last question. So it looks like a pretty awful rearrangement problem. Okay, first of all I've missed that line there, it's a fraction. So we have y plus 3 is equal to the square root of c times, in brackets, x squared minus 7 all over p. So lots going on. Basically give the equation for x in terms of c, p and y. So we basically want to have x equals. So what we're going to do is we're just going to take everything away from x. So I go with the analogy, you get up in the morning, it's socks, then shoes, and so we have to go back in that order as well. At the end of the day, you take your shoes off, then your socks. So we have to unravel this mess. First thing that we need to do is remove this big square root that's on everything. So we're going to square both sides. Now we have to square the whole side, not square y and square 3, but square that whole thing. That's now c times x squared minus 7 all over p. Next thing I want to do is I want to get rid of this p in the numerator and the c in the denominator. Well, I can multiply by the reciprocal of c over p. So p y plus 3 squared over c is equal to x squared minus 7. Getting close. Just going to add that 7 onto both sides now. P y plus 3 squared over c plus 7 is equal to x squared. and then I just want to get rid of that squared part. So I'm going to have to square root this whole thing. P, y plus 3 squared over c plus 7, and this is all being square rooted, and that equals x. And a little detail, if you square 9, then square root 9, 3 is obviously the solution, so is -3. So I'm just going to put a wee plus minus on the front because I'm wanting to show that I'm a bit of an expert. So yeah, that's obviously a pretty massive rearrangement. So I recommend maybe rewinding and just following through that again. Let me know how you found that. If you've got any questions, leave them below.